Examining relationship case C to C, categorical to categorical. To examine the relationship between two categorical variables, we display the data with a two-way table and compare the numerical summaries with conditional percentages or proportion between the variables of the explanatory variable, either row or column percentages depending on whether the explanatory sits in the row or column. But before we move on, to compute the proportion, we would take the count, how many, divided by the total, but not just any total, the total that we are interested in. To compute the percentage, we would do the same thing. Take the count divided by the total, but we need to do one more step, multiply 100%. Proportion is a number between 0 and 1. Percentages, it is in terms of percentage between 0 to 100%. When examining the relationship between a categorical variable and another categorical variable, we will construct a two-way table supplemented by the proportion or the percentages. For example, the University of California at Berkeley was charged with having discriminated against women and their graduate admission process for the fall quarter of 1973. So this is an old data, but this is a case study. The two-way table below shows the number of men accepted and denied, and the number of women accepted and denied for two of the university's graduate program. This is the study from Bickles and Akani, 1975. We are examining the relationship between the gender, in this case, men and women, that the gender categorical variable, and whether they are accepted or denied. This is also a categorical variable. And so this is the relationship between two categorical variables. In examining the relationship between two categorical variables, we will use the two-way table. There's a good chance that we are given the two-way table with the count. The way that we read the table is that there are 533 men who were accepted. There were 113 women who were accepted. There were 665 men who were denied, and there were 336 women who were denied. In completing the two-way table, the first step is always to compute the total of each row and column. In this case, we want to know the total male application. If we add the two numbers 533 and 665, we will get 1,198. This will tell us how many male applications total. Same thing, 113 plus 336 will give us 449. And then the row, how many accepted total, both men and women. In this case, if we will add 533 to 113, we will get 646. 665 plus 339, we will get 1001. Notice that to double check it, if we add the total rows and the total columns, we should get the same number. 646 plus 1001 will give us 1647. Similarly, if we take 1198 plus 449, we should also get 1647. And that is usually the third thing we need to do, finding the total of the columns and the row. Calculate the proportion of men applicants who were accepted and the proportion of women applicants who were accepted. There's a pattern in the question here. It is the proportion of men applicants. How many men applications total? There should be 1198 total. And out of 1198 applicants, how many were accepted. 533 of them got accepted. Similarly, for women, there were a total of 449 applicants, and 113 of them got accepted. We then use a calculator to find the proportions of these computations. 533 divided by 1198 will give us 0.4449 and so on. We're going to round it to 2 decimal places only, so this is 0.44. 113 divided by 449 is 0.25167. Rounded to 2 decimal places, this will be 0.25. In terms of the percentage, 0.44 is 44% and 0.25 is 25%. What this is telling us is that 44% of the male applicants got accepted and 25% of the female applicants got accepted. Now, if the question asks us to calculate the proportion of accepted applicants who were men, then we would find out how many accepted total, in this case 646, and how many men. So the computation would have been 533 divided by 646. So make sure we read the question carefully. Usually, the trick is the proportion of something, and the number of that something should go in the denominator. The proportion of men, how many men total? 1198 in this case. If the question was the proportion of accepted applicants, how many accepted applicants? 646, and so on. Next, the table below is identifying the number of acceptances and denials for both men and women applicants, broken down into 2 graduate programs identified as A and F. Notice that the column totals of the 2 programs match the counts in the two-way table. So for men, there were 533 accepted, 665 denied. For women, 113 got accepted and 336 were denied. These are the same value, the same numerical that we saw up there. There are 533 men who were accepted, and down here, this table gives us the same information. There are 533 men got accepted. There are 113 women got accepted, but this is broken down to 2 programs. Within each program, calculate the proportion of men. And so for each program, we're going to compute the proportion. We start with program A. Let's just focus on program A only. We will construct a table that is similar to the one that we did before. Men, woman, and then accepted and denied. How many men were accepted for program A? 511. How many women got accepted for program A? 89. How many men were denied for program A still? 314. And how many women were denied for program A? 19. And we're going to compute the proportion of men who were accepted. So we need to find out the total number of men who applied to program A. 511 plus 314 is 825. How many women are there? 89 plus 19 is 108. Recall that to compute the proportion of something, we need to have that number in the denominator. So if we're looking for the proportion of men, we put the total number of men in the denominator for program A. How many men are there for program 8? 825. And how many of them got accepted? 511. Put it in the calculator, we should get 0.62 rounded to 2 decimal places. Similarly, the proportion of women, how many women are there in program A? 108. And how many of these got accepted? 0.89. Put this in a calculator, we should get 0.82. What is surprising in this case is that earlier, before we broke down the data, we saw that there was a higher percentage of men who were accepted than women. But after we broke it down to its individual program, for program A, we see that there is a higher proportion of women got accepted. You should go ahead and do the same thing for program F as well. Follow the same procedure. There appears to be a paradox here. Men have a higher acceptance rate overall. Overall, men got accepted 44% of the time, and women got accepted 25% of the time. So men got accepted more. Yet, women have a higher acceptance rate within each program. We saw this in program A, and we will see it again in program F if you finish the computation. Using the data provided in the table above, explain how the paradox happened in this study. This is what we call a Simpson paradox. Notice that program is a confounding variable here related to both sex and admission decision. A confounding variable is a variable that affects the result. However, it is not included in our study. Remember that in our study, we only looked at two variables, gender and whether they got accepted or denied. We examined the relationship between gender and accepted or denied only, not the program itself. Whatever the program A or F, it might explain this contradiction.